Hello, my name is Heriberto Ramirez, but you may call me Eddie. In this presentation, we will explore the fascinating world of AI, its key components, and the technologies that enable its incredible capabilities. Let's begin. To begin, let's define AI. AI, or artificial intelligence, refers to the development of computer systems that can perform tasks that usually require human intelligence. These tasks include learning, reasoning, problem solving, perception, and understanding other aspects of natural language. Now, with that being said, this is an important breakdown, if you will, and I do want to take a minute here. AI is broadly categorized into two types of AI. There's narrow AI and general AI. We're going to go into these a little bit more in depth later, but for now, just remember that two of the types of AI are narrow and general. And at this point, I know what most of you are thinking is, what is an example of that? Could you actually describe that? So here's kind of my example for it. Narrow AI is also known as weak AI, and it's designed to perform specific tasks without possessing any genuine intelligence. So examples of narrow AI include recommendation systems on e-commerce websites, email spam filters, and voice assistants like Amazon's Alexa or Apple's Siri. On the other hand, general AI, or known as strong AI, refers to a machine with the ability to perform any intellectual task that a human being can do. General AI is also sometimes referred to as AGI. Now, it remains largely theoretical and has not yet, I would say, been achieved, but it should be achieved in the near future. Now, let's briefly explore the actual history of AI. The concept of AI dates back to ancient times, with myths and stories featuring artificial beings endowed with consciousness or intelligence. However, AI as a field of study truly began in the mid-20th century. And at this point, one of the main things that was the turning point was in the 1950s was Alan Turing's proposed Turing test, a method for determining a machine's ability to exhibit intelligent behavior indistinguishable from that of the human. This marked a significant milestone in the development of AI. In the following decades, AI research experienced several periods of progress and stagnation known as AI winters. These cycles were influenced by factors such as funding, technological limitations, and overly optimistic expectations, although I will say now, some of those overly optimistic expectations are becoming more and more a reality. But despite these challenges, AI has made significant advancements and has become increasingly integral to part of our daily lives. Thank you. So let's move on. But just keep in mind that for now, you know what AI is, you know that there's weak and general, and we talked a little bit about the brief history. So let's move on. Moving on. Now that we have a basic understanding of what AI is, let's discuss the key components of AI. There are three main building blocks: machine learning, natural language processing, and computer vision. These components work together to enable AI systems to learn, understand, and perceive the world around them. So let's dive right into the first one. The first component, machine learning, is a subset of AI that focuses on developing algorithms and statistical models that enable computers to learn and improve from experience. In other words, machine learning allows AI systems to analyze data, identify patterns, and make predictions or decisions without being explicitly programmed to do so. There are three primary types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is the most common approach in which AI systems is trained using a labeled data set. Common applications of supervised learning include image classification, speech recognition, and spam detection. Unsupervised learning, on the other hand, involves training AI systems using an unlabeled data set. And I think that's the key word, unlabeled. The system must identify patterns, relationships, or structures within the data without any guidance. Unsupervised learning can be used for tasks like anomaly detection, clustering, and dimensionality reduction. Lastly, reinforcement learning is an approach in which a AI system, typically known as an agent, learns to make decisions about its environment by interacting with it. The agent receives feedback in the form of either rewards or penalties and aims to maximize its cumulative reward over time. This type of learning is particularly useful for tasks that involve sequential decision-making, such as playing games, robotics, and autonomous vehicles. So let's look at some examples of machine learning applications. Image classification algorithms can identify objects within images, such as distinguishing between a cat and a dog within an image. These algorithms are often powered by supervised learning techniques like convolutional neural networks. Speech recognition systems, like those used in voice assistants, transcribe spoken words into text. These systems often rely on deep learning techniques, such as recurrent neural networks or transformers, to process and understand spoken language. Spam detection systems, which help filter out unwanted emails, use supervised learning to classify messages as spam or not spam based on various features like the sender's email address, the message content, and the presence of specific keywords. So that means that the second key component of AI systems is known as natural language processing, or NLP. NLP is a subfield of AI that deals with the interaction between computers and human language. It enables AI systems to read, understand, and generate human language in a way that is both meaningful and useful. Some common NLP tasks include sentiment analysis, translation, and chatbot development. Sentiment analysis, also known as opinion mining, involves determining the sentiment or emotion expressed within a particular piece of text. This can be particularly useful for businesses seeking to understand customer feedback or someone looking to gauge public opinion on social media. Translation, another common NLP task, involves converting text from one language to another while attempting to preserve its meaning. Machine translations, such as Google Translate, have improved dramatically in recent years thanks to advances in deep learning and neural machine translation techniques. So what about those chatbots? Chatbots, conversational AI systems, are designed to interact with users through natural language. They rely heavily on NLP to understand and respond to user input. Examples of these chatbots include support bots, virtual assistants, and even AI-powered mental health chatbots. Which does bring us to the third component of AI systems, which is computer vision, a field that enables computers to gain a high level of understanding of digital images or videos. This understanding allows AI systems to recognize, interpret, and process visual information in a way that simulates human vision. Some common computer vision tasks include object recognition, facial recognition, and image synthesis. Object recognition involves identifying and classifying objects within images or videos. This can be useful in applications such as self-driving cars, which need to recognize and respond to various objects like pedestrians, traffic signs, or other vehicles. Facial recognition is a specific type of object recognition that focuses on detecting and identifying human faces. Facial recognition systems can be used for various purposes, including security, surveillance, and social media tagging. Lastly, image synthesis, another computer vision task, involves generating new images based on certain input parameters or constraints. This can include tasks like style transfer, where the style of one image is applied to another, or image inpainting, which involves filling in missing or corrupted parts of an image. Therefore, in order to perform the complex task we've discussed, AI systems require powerful hardware and infrastructure. Some of the most important hardware components that power AI systems include central processing units, CPUs, graphical processing units, GPUs, and tensor processing units, TPUs, and neuromorphic chips. CPUs are the general purpose processors commonly found in most computers. They're versatile and they could handle a wide variety of tasks, but they may not be the most efficient choice for AI workloads which often require high levels of parallelism. GPUs, originally designed for rendering graphics on the other hand, have emerged as a popular choice for AI workloads due to their ability to process large amounts of data in parallel. This makes them rather well suited for tasks like training large neural networks, which involves performing many matrix multiplications simultaneously. TPUs, developed by Google, are application-specific integrated circuits designed specifically for AI and machine learning workloads. TPUs are optimized for low-precision arithmetic common in AI computations, providing improved performance and energy efficiency compared to CPUs and GPUs. Lastly, neuromorphic chips, inspired by the structure and function of the human brain, are designed to mimic the way neurons and synapses work. These chips can potentially offer significant improvements in power efficiency and performance for AI applications, though, and here's a caveat, they are still in the early stages of development and adoption, but I guess on the bright side, are rapidly developing. In addition to hardware, AI systems often rely on cloud-based platforms that provide the necessary computing resources, storage, and tools for AI development and deployment. Examples of these platforms include Amazon Web Services, Google's Cloud Platform, and Microsoft Azure. Therefore, to process and learn from data, AI systems rely on a variety of algorithms and models. Some of the most common AI algorithms and models include neural networks, decision trees, and reinforcement learning algorithms. So what are these? Neural networks, inspired by the structure and function of the human brain, are a type of machine learning model that can learn complex patterns and representations from data. Deep learning, a subfield of machine learning, focuses on training deep neural networks that have many layers that are used to solve challenging tasks such as image recognition, natural language understanding, and speech recognition. Decision trees are a type of machine learning model that can be used for both classification and regression tasks. They work by recursively splitting the input data based on specific features, resulting in a tree-like structure, and hence the name. Random forests, if you will, which consist of multiple decision trees, can provide more accurate and robust predictions by combining the outputs of individual trees. Reinforcement learning algorithms, as mentioned earlier, are a type of machine learning approach that enables agents to learn by interacting with their environment. These algorithms often include concepts like exploration versus exploitation, state action reward state action learning, also referred to as SARSA learning, and Q-learning. Therefore, as AI systems become more integrated in our daily lives, it is essential to consider the ethical implications and potential biases that can arise in their development and deployment. Some of the key ethical concerns surrounding AI include data privacy, transparency, accountability, and fairness. One of the most significant challenges in AI ethics is addressing biases within AI systems. Bias can emerge from various sources, such as a bias training data, flawed algorithms, or even unintended consequences of human decisions during AI development. To mitigate bias in AI systems, it is crucial to do three things. The first one is collect diverse and representative training data, ensuring that unrepresented and marginalized groups are not excluded or unfairly affected. Second is to conduct regularly audit and evaluate AI systems for potential bias using methods like fairness metrics, adversarial testing, or external auditing. And third and lastly, develop AI systems with transparency and explainability in mind, making it easier for users and regulators to understand how the systems are making their decisions. That will conclude this lesson for the most part, but before I let you go, some of the recaps and key takeaways here, and in the future presentations, or the future lessons, if you will, I will be going a little bit more in depth, but for now, I think one of the key things that we can take away is that AI is complicated. Second, we understand the three components of AI, right? They are machine learning, natural language processing, and computer vision. And third, once we put all of this information together, there is an understanding of ethics and bias and how they will continue developing well into the future while also trying to balance the needs for users and regulators alike in our modern day environments. So thank you very much for joining me in this introduction to AI and its underlying technologies. I hope our discussion has inspired you to think more deeply about the role of AI in our world and to take an active part in shaping its future. Thank you.